And so to kind of frame this discussion, I've got a pretty unique panel here, technology owners, designers, to talk about this. So let me introduce you to my panel, and then I will turn it over to them. Our first speaker is going to be Cora Commodi. She was most recently the global CIO and vice president for IT at Jacobs, some small $12 billion firm with about 66,000 employees. 70,000 employees, there we go. She was responsible for a lot of the things that we're going to be talking about around enterprise resources for HR, operational support systems, project controls, engineering design and collaboration, infrastructure systems, network servers, desktops, and especially as we get into this whole Internet of Things, the web and social aspects and collaborative systems that is now parading through most firms. This past October, she left Jacobs and on her sabbatical is pursuing a course in the Internet of Things, which I hear she's almost done and ready to come back to the real world. Next on our list is John Kirschner. You heard a little bit earlier this morning. He's one of the supporters of the Blueprint 2025. He's the Senior Vice President at Globecom. He leads the development, implementation of their strategy and product, both global, corporate, and product strategy. Prior to that, he was the Chief Operating Officer at GeoOptics, an early-stage satellite-based environmental data services company. He's also served as the Executive Vice President and General and Manager for Akia Satellite Media, managing their operations out of Washington, as well as Laurel Space and Communications, where he managed the Laurel Alcatel joint venture in the UK. Next to him, hey, they got the orders right, is Tim Mcmanus. He is now the Vice President at McKinsey's Global Infrastructure Practice, leading their major project delivery group in North America. His focus there is helping to develop, implement, and deliver mega projects. And you might, for those that don't know him, know why is that the case? Well, he worked for another small firm called AECOM for a number of years, a $19.5 billion firm with 95,000 employees, and he led the planning, development, and implementation of their major capital programs for infrastructure. And the cool note I always like to throw in, and prior to that, he was a member of the New England Patriots football team, for those that don't know him. And he built this small thing called Gillette Stadium as program delivery. So if you've ever been to a Patriots game, you can thank Tim. Next to him is Dareen Salamala. She works for STV, a engineering and firm. She is focused on the virtual design and construction platforms, linking the aspects of project management, construction management, cost schedule, and facility information, leveraging BIM technologies. She is currently working as the Assistant Project Controls Manager for the LaGuardia Airport Redevelopment Program and leading the implementation of multiple technologies, including mobile applications, BIM, and project information systems. And last, but certainly not least, our owner representative, Michael Salvato from the MTA. You've heard from Michael a couple times today. He's responsible for $1 trillion worth of infrastructure assets through New York City. The MTA is the largest public transportation provider in the Western Hemisphere. Its agencies serve approximately 14.5 million people and are spread over 5,000 square miles. And they move about 8.5 million people a day. So, and he focuses on leadership and asset management, well beyond the MTA, because he's also the chair of the Institute of Asset Management U.S. chapter and is a thought leader on infrastructure management and smart cities. So with that, I will turn it over to our panel, and first commentary will be from Cora.
All right, thank you. I decided not to use slides because I don't want to put you to sleep. Don't want to get trapped into reading the slides. So the Internet of Things. This morning in the Smart Cities discussion, I gave by the way, I've been a CIO for the last 19 years, and the comment I made this morning was a 10-year-old comment I made to a CEO on an IT budget discussion. Better, faster, cheaper, you can choose two. Well, now with the Internet of Things, or what Prime Minister Cameron has called the third industrial revolution, I think we're closer to the point of getting all three, and then some more value. But I think that it hasn't really been a revolution. It's been creeping in many ways. I think the Internet of Things really owes its existence to the legacy of moving telephony from analog to digital as a first thing. And we hadn't talked as much about the communications, but I will today. But we've talked about sensors. And if any of you travel a lot in airports all over the world, you might have a tendency to come home, go into the bathroom, and stick your hands under the faucet and wait for the water to come. That's an example of sensors without connectivity, but with the associated actuator or effector. I mentioned to a table mate today that I spent 6 years on the first space station program, and the space station, in its sense, was nothing but a network of sensors and effectors around a FDDI, a fiber data ring. As the world has evolved, we also saw in the early 2000s a grasp for a real-time enterprise, and people like Delta Airlines put IP addresses on the luggage carts so that you would know at any point in your after landing where the luggage was on the way to baggage claim. And you may have been in hotels. I know I was in one in Italy in about 2002 where even back then, as soon as you pulled a Diet Coke out of the refrigerator, it showed up on your hotel bill. And here's where I, as a CIO, have to talk about the back-end processing. And the Internet of Things wouldn't be anything if it didn't have corresponding integrations into the back end. You want to be able to invoice quickly. You want to be able to pay your people quickly. You know, field time card systems are probably one of the more archaic still on craft and field labor sites. But the faster you get accurate time cards, the faster you can invoice depending on the contract type. There's been a lot. The supply chain has moved earlier with some good things, some bad things, to integrate the Internet of Things. I, this morning, used the example from JCPenney, an early, not so successful integration of RFID tags in the supply chain. That brings me to the point of one of the issues is how do you separate the hype from the truly benefit? You have to do a cost benefit and move away from the buzz. And that's where I think having innovation labs, collaboration, but you know, think tanks to be able to really do proofs of technology before you go all global, like unfortunately JCPenney did to a huge financial loss. At the, this morning, I also mentioned that smart cities are not just smart because of the sensors and effectors, but it's because of the data that those sensors generate, and then the decisions on what to do with the data. So you can't really talk about the Internet of Things without talking about big data, business analytics, and actually being able to do something in more real time than you could in the past. Here again, as a CIO thinking about the back end, most of the data that CIOs and traditional IT shops deal with are structured data, not the free-form sensor data of big data. So the integration of both, what are you going to do with the data? It's also true that you need to move the data processing closer to the source of the data, because you get time lags, and if you're dealing with a volume of data, you want to be able to process sooner rather than later. And one of the things I've been studying in my sabbatical is the different microprocessors. I've been using the Dragon Board 410C, which has a Snapdragon, a Qualcomm Snapdragon chip. But then there's the Intel Edison and other microprocessors that really make the ability to have a data center the size of your telephone integrated into a refinery or other things. The other thing that the technology change has brought has been a whole plethora of sensors of every type imaginable. Humidity, temperature, at low cost with low power requirements. But again, it's the data integration, what to collect, who do you trust? In CIOs, you have a single system of truth for employees in time and for financials. How do you deal with that in the Internet of Things? Then the last thing I really want to talk about, I started with communication and the legacy of communications protocols that the Internet of Things owes it to. We've heard different estimates of how many devices, how many embedded sensors and actuators would be in place by 2020, 2025. And I've heard numbers as high as 50 billion. And if you think about the Internet protocol structure of IPv4, it can't deal with the number of devices that will need each unique IP addresses, and that's where some of us were around and CIOs at the turn of the century with a big Y2K scare, which turned out to be not as bad. It turns out in the 70s, people didn't think about hard coding 4-digit years. They just assumed it would be 19-something forever. And you've got that in the IP addresses and, quite frankly, in the area codes in the United States. We have, each house now has more than one device with its own phone number. So I'll just throw that out and let you go with it.
Okay, great. Thank you.
Yeah, great, thanks. Good afternoon. Certainly some of the things that Cora's just mentioned I will touch on. Although I think McKinsey actually thinks there's a trillion devices that are going to be connected in 2025, or a trillion. So in any case, so a few things to touch on here. Again, to be somewhat repetitive, I see this world as very rational, very ROI driven. I did mention this morning that there are other planes, whether it's public safety, revenue, quality of life, but a lot of what's driving, as we see it both in commercial and in government sectors, is really about ROI driven. Reduce costs, reduce risk, and become more efficient. And that's really these aspects of automation, actuation, optimization, that are really serving the needs of infrastructure as well as public safety organizations. But I ultimately think about this in the construct of DNA, and Cora touched on some of these, so I try not to be not just competitive, but repetitive. But we talk about these in terms of DNA, and it's not just your DNA, it's the DNA of the device, the network, and the application. There's an incredible amount of innovation taking place at the device level, at the sensor level, at the connectivity aggregation level, multi-mode, satellite, cellular, low power and no power, essentially effectively no power sensors. So there's a lot of innovation opportunity there. In the middle is the network. At the end of the day, you really need something to connect to that device to get the data, and the network has all of its different forms. It is inclusive of satellite, but much of it's cellular. And if you think about the trillion connections that, whether it's McKinsey or others might say, the connections are really it's connecting out to a sensor that could be low power connection that then aggregates to a satellite connection or a cellular connection. Cellular, while it's ubiquitous, may not have as many connections as Wi-Fi might, or Zigbee, which is more the extension of the network beyond cellular. And on the far right-hand side of the picture here is really the application and data. Garbage in, garbage out, tons of volume. If you don't know how to aggregate it, you don't know how to organize it, you don't know how to use it, it really is quite, I think, quite irksome and useless. And it really takes skilled people in different verticals. We serve areas as a company in the maritime industry, certainly oil and gas, government, media and entertainment, which is a little bit different. But the bottom line is there's a ton of information, ton of data, and that data is not just data, it's actually video. And you need an asset management capability to manage that kind of information just as much as data. This is something I've come to believe about the Internet of Things. I actually don't care for the phrase. Sorry if you're from the Silicon Valley or you invented it. It's a very technology push phrase. I actually think that the Internet of Things isn't something that somebody set out to do. It's actually something that sort of happened to us. And I think it's happened to us in many respects because of these trends that you see up on the slide, which sort of starting with lower cost, the low cost of data, its storage, the cloud, the tools that we use to manage it. The cloud is such an inexpensive, so scalable, and really makes data management a whole lot easier. Then you've got bandwidth, which whether you're on the ground or you're in space, there continues to be more bandwidth added, let alone used, and it gets more efficient. There are compression technologies that make that additional bandwidth have an exponential factor. And frankly, with all these connections, it will be eating up a ton of bandwidth. So lower cost bandwidth and a lot more of it. Cora's already talked about the sensor. Sensors are getting smaller and smaller and smaller. They're getting cheaper and cheaper and cheaper. And frankly, it gets down to business models. Nobody would do the Internet of Things if it didn't make money or it didn't give ROI. So that's really what all these factors are really driving to is, benefit at a much lower cost, let alone the technological capability. And then from a satellite industry perspective, and I hate to, I have to throw that in there a little bit, space, seems that it would be quite complex and challenging to get to and expensive. It certainly used to be. But today you can get a 10 by 10 by 10 centimeter CubeSat in orbit, pack them on a P-pod, as they call them, and get them into orbit at about $150,000 to maybe $200K a pop. And they have depending on which ones we're talking about, maybe 5 to 10 years of life. Very inexpensive. And you almost treat a satellite like a razor blade for the men in the house. So it really is a changing landscape when you add that kind of capability coming from space to the terrestrial environment where we have bandwidth. So really to finish, it is about an ecosystem. We don't do it all ourselves as a company. I don't think anybody in here does. If you do, you're probably going broke. But it really is about getting partners and capabilities together. We're a systems integrator, a solutions integrator, and we could not possibly afford to do it all ourselves. But that's a bit about how we see the world.
So thank you. So much to the surprise of everybody in this room and probably everybody in this conference, you're probably wondering, what is McKinsey doing here? Right?
You made a big prediction.
But over the last 5 to 6 years, we have been involved in the development, management, or structuring of over $1 trillion worth of capital projects across every continent. We don't get called in to do the same things that a lot of other providers do in terms of construction or design, but in terms of how do we structure these programs to provide the utmost value for a client, whether it's a government or whether it's a Fortune 100 company. If you look at the numbers, many of you are familiar with the McKinsey Global Institute, and right now, you've seen a lot of numbers this morning, a lot of the presentations. We're predicting that between now and the next 15 years, total of about $57 to $60 trillion has to be spent on infrastructure to bring it up to a state of good repair in order to stay in tune with GDP growth globally. And if you look at that, if you look at the funding sources, as you've seen before, funding sources are not there. So we have to look at how do we do things smarter? How do we drive value into these projects? How do we create value in unique ways that hasn't been there before? And what we've looked at is how do we apply technology to do this, whether we're looking at a public-private partnership, whether we're looking at a capital program for an African country, or for a major corporation that's looking to expand. So when we look at that, we've also seen, and we've published last year, how the Internet of Things is capable of providing approximately $11 trillion of GDP to the world through its applications. We've also seen how the Internet of Things can drive value into infrastructure projects in unique ways. So what I'd like to do is talk about 3 things today. Talk about how the use of big data or advanced analytics can look at projects and prevent disasters by projecting ahead. If you look at the work that we do, any of the projects that we've all talked about, these are not unique. They're all very similar. They're all repetitive. But if you look at the issues that occur with them over and over and over again, somehow we have to leverage that knowledge in order to roll it forward so we don't repeat history. The second thing is, we've talked about many trends. We've identified, 5 major transformative trends in technology that are shaping the infrastructure industry. You've heard about a lot of them already today. But the last thing I want to talk about is how we have, I'll give you 2 examples of how we've applied the Internet of Things to 2 major capital programs in the world to drive value into them. First of all, when you look, we did a survey about a year or 2 ago of mega projects around the world. And what we discovered that approximately 98% of these mega projects throughout the world either have a cost overrun or a schedule overrun. And you look at that, and you look at the value of those. You look at the cost overruns of significant amounts of money of 80%. You look at schedule overruns of 20 months. You analyze this, and what we did, we then looked and said, what are the causes of these? And if you look at the traditional technical causes, you look at the traditional execution issues. What we also see is the commercial and the management and organization aspects of these is what drive these problems over and over and over again. So we have this tremendous database and look at that, and we say, okay, that's great, that's really interesting. What do we do with it? So we created a system called NERV that combines the analysis of hundreds, if not thousands, of projects around the world, creates a connection database to look at similar projects in order to predict behavior. So how do we prevent these same things from happening again so we don't have an 80% cost overrun, so we don't have a 20-month schedule delay? And how do we apply those in predictive analytics to show how these projects can be driven in on time and on budget at a value that is far better than was ever anticipated? So trying to apply major or advanced analytics and big data certainly has enabled us to do that, and that's what we try to do. We don't come into a project, I was shocked when I've been with McKinsey for 5 months, and I was really surprised when I said, I've got a couple of opportunities where clients want to bring us in, help us manage the project. And the firm looked at me and said, no, we don't want to do that because it's too late in that project and we're not going to be able to drive the value into that project that we would like to. So we'll only take on an engagement with someone for a major program if we think that we can provide tremendous value by lowering the cost, increasing the value of that project, bringing it in earlier, and doing that. So these are the tools and the systems and the methodologies that we need to apply. You've looked at these trends. You've heard them from several groups already this morning. The thing about these interesting trends in technology, whether it's the Internet of Things, whether it's BIM, whether it's better survey and mapping, it's imperative in our industry that we get out in front of this because if you look, we all walk around with one of these, and if you look at these, you go back 5 years ago, you go back 10 years ago, it was nothing like this. So the advancement of technology, the trending of technology, and the application of it is becoming much more of a real-time basis in a much more cost-effective way. That's what we're looking to do, is to bring those technologies and those uses to better applications in order to drive value. 2 examples. As a way, McKinsey, as you know, is a very analytical firm, very quantitative analytical firm. So that's why I have to give big numbers. I feel negligent if I don't give you big numbers. I've got to say something like that. But last year, in order to advance our analytical skills, we acquired a company which was the premier data analytics firm in the world, Quantum Black. Now, Quantum Black, for any of you who have not heard of it, Quantum Black started as a big data or advanced analytics firm looking at the Formula One racing industry. And what they did and what they analyzed using Internet of Things as well as big data was to analyze and predict the time trials of Formula One race cars. How can I shave a second or 2 seconds or 5 seconds off a car, off the maintenance, off the fueling, or any of those aspects of it that can give me a competitive advantage? And they did this for all of Formula One, then they advanced that to other sports industries, and then they went into other industries as well. So through the work of Quantum Black on a project called Crossrail, I think most of you are familiar with Crossrail in the UK, $24 billion program, 100 kilometers long rail program. Crossrail was spending, they had about 40 kilometers of tunnel boring machine work in London. And Thomas Mayer, you experienced it, and you lived with it every day as you went to work. So 40 kilometers of tunnel boring machine work. Crossrail was spending 130 million pounds a year on inspection and monitoring. And it was being done in a way that was very traditional, and they were reporting what actually occurred. Writing down the reports, out taking that data, and it wasn't getting anywhere. So Quantum Black teamed up with Arup and Atkins, developed a network of hundreds of thousands of sensors in the tunneling work that went on to not just track and inspect and monitor what was happening to soil conditions, structural conditions, tunneling patterns, but how could they take that and predict what was going to occur next or predict how it was going to advance in the future. And through that application, it provided a much more realistic forecast of the tunneling work. It enhanced the risk management of the project, but also decreased the cost for inspection and monitoring by 20%. And this was done as the project was moving on. So if it had employed earlier in the life cycle of the job, it would have resulted in even more significant savings. So that's one application. Another application, if you look, there we go, for a major highways program in the UK, Quantum Black was brought in as well to look at how can we drive 10% out of a concession that was responsible for the design, build, and maintenance of a major roadway system. So they analyzed, but what they did, they took the application of big data as well as the Internet of Things, applied it to every one of the databases, not just the physical assets, but the human behavior characteristics, the design work, the maintenance work, the supply chain, connect all those, analyze them in terms of behavior, predicted analysis, and as a result came up with a 17% budget reduction for the entire program, hundreds of thousands of millions of pounds, to reduce that by 17% just through a better application to be able to forecast more effectively using big data. So if you look at these aspects, the 3 points I'd leave you with. Number 1 is the use of predictive analytics in order to deliver projects more effectively, more reliably, and cheaper. Number 2 is trending, seeing how those trends of technology applications are going to affect and how you can advance them in the future. And then number 3, how to apply the Internet of Things in order to drive value and reduce costs of a major project. Thank you.
All right, so just a quick overview of STV and what I do before we get started on some of the applications that we're working with today. So STV does design and construction management. My primary focus has been on construction management, and that's where the applications that I'll show today are. We've been in our journey of implementing technology, BIM, certainly not at the level of IoT yet, but I'd like to show the different applications that we do today and the potential, with some things that Tim touched upon, the potential for us from doing it traditionally BIM-wise and then in the future with sensors and IoT technology. So we've, similar to different slides that you've seen today with the different technologies, we've kind of categorized them in 3 different levels within our company and our group. Part is the traditional project controls of managing cost and schedule on projects and estimating and schedule reviews and such. And then part focuses primarily on BIM, and part is the emerging technologies that we're talking about today. So as Tim mentioned, we currently monitor construction projects and inspect projects. And the way we do that is using mobile technology. We certainly don't have that level of sensors, and that would add a huge added value for us. Just by having this as what we call real time of walking the site and being able to update the model on an iPad and being able to quantitatively evaluate where we are in terms of productivity in comparison to our baseline. So what you see there, the curves up there, those are produced directly from the model quantities. And I'd imagine if we'd have a system that connects to the manufacturer data to have, for example, delivery, then we could really catch productivity before the problem starts to occur. Here we start predicting trends with the green curve approaching the blue line. That means that we're about to be delayed, and that gives us opportunity to act before the problems happen. The bottom chart coming directly from, again, our mobile applications with the use of vBuilder as our project management system with inputting manpower from the daily reports, from the inspectors, and compare that manpower in comparison to productivity of work in place. And in the future, I foresee that with either RFID tags or the sensors on site, or using video footage from site to evaluate how much manpower is there. And therefore, we could do this much faster, and this was already 10 times faster than we do it the traditional way of 2D drawings and evaluating schedule of values and payments and invoices. But with sensors, that would be 100 times faster than it is today. The other thing I wanted to touch upon is also from an asset management standpoint. So again, the traditional way was to have the equipment on site. Once it's delivered, you have hard copy checklists, and you go through those and identify whether the equipment is online or not, or passed tests or not. And by the time that information travels from the site back to the manufacturer that there is a problem, or that the piece of equipment delivered was not the right one, or it's not interoperable with the system that we have in place, that would be too late and delays the project schedule. With us, we started monitoring that with the BIM model. Again, we update the information electronically using mobile applications, but then, again, if the equipment itself was connected to our platform, then we could have a much faster response time. Oh, I'm missing something. I don't have the slide, but so part of what we're doing at LaGuardia Airport is really combining all the information from the different models that we have. So we have maybe at least 10 projects that are ongoing, small or large, at the airport. And part of it is combining all the information in one place. And with data analytics, for example, traffic footage, traffic analysis of what the construction will, how the construction will affect traffic, how the construction will affect bus routes. So we've been using a lot of data analytics and information that's coming from New York City open data to evaluate the effect on bus routes and effect on traffic. So that's been a tremendous value for the airport. And in addition to that, not just focusing on projects, but also focusing on corporate data where we can really tap into a complete database. So all of our estimating database, we can look at any type of data analytics there to look at what the cost is of a project right before we start from similar historic projects that we've had. And not just that, but also the ability to use natural language processing so that you can literally, today you have trouble going into the system and trying to find the information you're looking for, but almost having a Google-like system where you can search your company corporate data, and then the information would pop up in different formats, and it would be dynamic for the user so that you can pick and choose what type of data you want as opposed to wait for someone or an analyst to produce a report for you. All right, thank you.
Hi. As we've been talking, digitization is really transforming the way we plan, build, operate, and maintain our complex infrastructure systems. At the MTA, I serve sort of as the chief evangelist for asset management and kind of the key change agent for the chairman and the executive committee. And we're managing a fairly substantial, nearly $500 million change program to put in place new asset management practices that really leverage information technology to, provide better safety, reliability, customer experience at lower cost and lower risk. So digital infrastructure is really not simply technological. It's economic, it's social, it's political, it's very disruptive, and it's really absolutely essential. Back. So much of our, take this simple bus, we're equipping our fleet with onboard sensors, communication systems, and processors. This will provide passenger information and operators' route updates. It'll enable the bus to interact with its surrounding for safer, more efficient travel. It'll communicate with the operations centers of our own, but also with other service providers, as well as automatically signal the need for repairs at the slightest hint of a trouble or malfunctions. Game-changing innovations such as on-demand services, asset sharing, autonomous, and interconnected vehicles are really changing the way surface transportation works. The impacts, however, go far beyond transportation. Innovation in sensors, as we've been talking about, actuators and signals will really shake up the entire supply chain. It'll disrupt business models and existing markets for energy, water, buildings, security, and other sectors. A whole new field in urban informatics is making sense of big urban data. At New York University, we launched the Center for Urban Science and Progress as part of Mayor Bloomberg's Applied Science Initiative in 2002. In full operation, this research center called CUSP will have over 700 data scientists working to help cities become more productive, livable, and resilient by data analytics. And Simon Sylvester, as we talked about, we're working with the mayor's office to host Smart City Expo and Congress in October. I really hope some of you will join us there. We've been talking that the Internet of Things will really unleash an explosion of innovation has, for now, remained largely out of sight and underappreciated, and we've really begun to just scratch the surface. At the MTA, we're developing a new enterprise-wide asset management information system, and we're integrating our EAM system, our new EAM system, with our existing ERP system and with our enterprise GIS platforms. We're introducing new business intelligence and decision support and visualization tools to support our managers. In the next 4 years, we're going to put out 15,000 mobile devices to our maintainers, and we're starting to look at remote condition monitoring tools to help us with that maintenance. But technology by itself, however, is really insufficient. Business process reengineering will be essential to adapt to more instrumented, interconnected, intelligent infrastructure. And to work smarter requires literally radically new business models, delivery approaches, business rules, and cultural norms. A common rule of thumb is that 70% of technology-enabled change projects fail. And then, so how can you deal with the complexity of infrastructure at a city scale? First is to recognize the need to change. Doing things the way we have in the past is really a sure way to failure. And while cities may differ, they all share a common goal of becoming more socially, economically, and environmentally sustainable. And the British Standard Institute we've been talking about has defined smart cities as an efficient integration of physical, digital, and human systems in the built environment to deliver sustainable, prosperous, and inclusive future for its citizens. A smart city uses this technology to radically improve the pace of sustainable outcomes, the benefits that we've been talking about. And smart cities projects involve teams and companies from an array of disciplines and sectors. And until we align our methods, it's going to be very difficult and risky to deliver these digital projects. A shared framework enabling large-scale deployment of smart cities technologies is still missing, particularly in the United States. And without it, cities will be marred in suboptimal outcomes, higher cost, and project failures. The MTA is using ISO 55000, the new international standard for the management of physical assets, which we helped write, by the way, to fundamentally redesign our management systems. We are also introducing international practices developed by the Institute of Asset Management, again, which I chair in the United States. And it's these open standards and technical specifications that are essential to assuring coordination, integration, and interoperability for these complex systems across the various silos, both within our organization and between organizations. These standards really will provide us the vocabulary and the various actors in the process to have the same definition and align around the same objectives. This also allows for easy benchmarking, knowledge transfer, collaboration between operators and service providers, and quality assurance. And these standards are essential to keeping markets open for competition and innovation. And because of our commitment to international standards, the MTA has been able to acquire forward-leaning asset management practices from Australia. We've acquired an asset information model from Britain, and we've been taking in technologies from around the world. This diagram comes from the British Standard 1192 for BIM, Building Information Management, which we've been talking about. In Britain, as we've said, that the central government has mandated level 2 BIM on all public projects by 2016. This program is credited with securing over 20% savings in CapEx and 30% savings in whole life costs when compared to benchmark projects. This was level 2. The government has committed to level 3, which is known as Digital Built Britain, which focuses on cross-sector collaboration in procurement, delivery, and operation of the built environment to really realize fiscal, functional, sustainability, and growth objectives. Very ambitious, but again, it's that mandate. And the BIM innovation was central in Crossrail and High-Speed Rail 2. And it's also contributing to the UK's comparative advantage right now in digital technologies in what is, a $15 trillion global market for infrastructure and construction. The MTA is adapting or adopting 1192 for our project and asset information models, which we'll find as the foundational building blocks for the use of the Internet of Things, digital infrastructure, and smart cities. Oh, it moved on by itself. The transformational power of digital technology has been demonstrated in many industries, but as we've been talking about, the infrastructure has been very slow to adopt these innovative ways of working. Some owners, builders, and operators are changing how they approach, and we've seen some examples today, applying these to improve performance, but also embracing the concept of the triple bottom line for social, economic, and environmental sustainability. And countries like Britain have developed very robust national strategies for digital infrastructure, for smart cities, and really the entire information economy to deliver these services to citizens and really to maximize the social benefits of these technologies. With the challenge of climate change and again the potential of smart cities really require radical changes in the way we plan, build, and manage our cities. And it's really time for us to recognize the need for these changes and make the changes that are needed for this innovation in our infrastructure. And through this, together, we can build a digital infrastructure for smarter, more sustainable, and resilient cities. Thank you. Oh, it moves on its own. All right.
Perfect.
Thanks.
Thank you all. Lots of good information. Before I turn it over to questions from the audience, and we'll want to make sure you make for a microphone so we can record it, I'm going to take the moderator's choice and ask the first couple, so I can do that. There was a lot of discussion up here, I think, all across the board about, hardware, software, big data, all being tied together. So, I mean, you mentioned it, that it's really hard to have any device, any piece of infrastructure where the hardware and the software are separated, right? They're almost ubiquitous. It's got to be like a system of systems. So how does that change from your perspective when you're dealing with something that is so integrated that it wakes up and is smart, but at the same time, it can also be more catastrophic when something goes wrong? What do you see as the value change here when you go through these things? I'll start with you, Michael, since you're just right on top of it.
So, I mean, have a physical civil infrastructure. We now then added a kind of electromechanical infrastructure on top of that, and now we're putting on top of that what we might call the infrastructure. It really does change our approach to how we manage our physical world. It'll all be mediated through this information technology, and some of it increasingly will be automated through sensors and other activities. I think two things that I'll just kind of say. One kind of is that it takes systems thinking fundamentally, and the importance of systems engineering in this type of methodology. And again, we've been talking about standards and things like that. It's really incredibly important to have that type of traceability that a systems engineering approach brings to these complex systems. You have to be very disciplined in that sense. So modeling becomes increasingly important, I think. Sometimes I've said if you really wanted to just change the organization, you needed to hire about 40 or 50 systems engineering graduates and just let them do their job, and in a few years the organization would change. The other thing is that we're looking at is changing our specifications, which for us, I mean, introducing information as a requirement within our specifications so that from the very beginning, as soon as you start building a project or an asset, that the information requirements are known and the builder is accountable, the designer is accountable for producing that information, the builder is accountable for managing it, and that it's handed over in such a way that the business can accept it. So for the purposes of accepting an asset, I've seen people go so far as an asset does not exist until it exists in the information system of the company. It's not accepted, it's not a real asset until the digital representation is managed by the owner. So that's a kind of two different examples.
Okay. Well, actually, let me move down the table. Can go to both actually Tim and Doreen on this. If Michael, as the owner, is going to be able to spec this type of system type delivery, what do you think the engineering providers, are they ready to be able to deliver this? Is this something you're waiting for, or is this going to be a oh crap moment, we better do something different?
All right. So my personal response is that it's a mixture of both. So Michael mentions organization. The organization of how we as a company provide our clients with a construction management team or a design team or a full service design and construction management team, that changes. At first it started with, let's have a group of, let's say 5 or 6 on a project that understand the systems, that understand the technology, understand the specifications, and can deliver and support the rest of the team. In construction by nature, you've got people who have been in the business for 30 years or longer and have done this in a different way. And then you have that mixture of 6 people are asking a whole team to change their way of thinking and to change their way of delivery, while the rest of the team is expecting those 6 people to do magic. And that has become, that's challenging. Some companies are more ready for it than others. Some companies have approached it in an integrated way, in an integrated manner, and others haven't. So from my personal perspective, I can't wait for an owner to say that, because I'm on the side where I'm convincing the clients that this is needed, or I have maybe 1 or 2 champions within a client organization that support this, but then you get blocked by either contract delivery methods, procurement, cloud security, which we're working a lot with these days, and divisions within an organization. And currently, with my experience with the Port Authority, I think we've worked together with them, and we both have reached a point where we really broke down a lot of walls between the different divisions. Like I mentioned, traffic, security, technology. Everyone is starting to realize that in order to deliver this, we have to work together. And with smaller projects starting to come online, people are realizing that, very quickly realizing that, oh, what you were telling me 6 months ago, I need it now. And that's really serving as a very quick lessons learned, with one project being offline, completed, and then one project coming online, and transferring that lesson learned very quickly to the new projects.
One more thing before I hand it to Tim. Business opportunity for engineering firms?
It's huge. It's great.
Okay.
We can't wait for that. Yeah.
Okay. Tim, I got kind of a refined question for you, given your background.
Now you're changing questions, just what I had the
Same
answer to your
question, just
previous
different
question.
angle. You know, when you start listening to what Michael said and, you know, the delivery side of it, you know, we have this thing called construction that we'll have to embed a lot of the smart stuff. But then we have this thing called a contract, right? And they're not the same thing. Contract is not construction. You know, thinking about the program delivery that you've done for many years, how does this change that? I mean, you know, when you think about making this happen.
Well, I think it's a very good question, Terry. That I think this old adage of you have to lose so I can win type approach in the delivery of projects is becoming arcane.
That's my
if you look at the success, you know, if you look at the difference in project delivery with public-private partnerships versus a traditional methodology, there's a win-win there for everybody. If you look at the results of alliancing in Australia, where the 3 parties come together as one entity to deliver a project more effectively, the results are spectacular. So I think by specifying, by looking at these things from a contractual basis, how do you develop that win-win scenario where I can develop this project quicker, I can do it for less money, and I can create an asset management tool on the day of substantial completion that the owner has that will improve the life cycle of that asset. If you look also, the other key aspect, I think, is if you look at the infrastructure demands throughout the world right now, we can't rebuild it all. So I think if you look at the Internet of Things, if you look at big data analytics as a way of improving capacity management on these existing assets, whether it's, you know, if you look at driverless cars, you look at all this other technology that's being applied now, somehow we have to create a better demand modeling and capacity utilization of these existing assets and take advantage of them like that.
Okay, excellent. John, comments, questions?
I guess I would say that from Globecom's perspective, we are learning how this sector buys and analyzes its infrastructure needs. And I say buy, I mean literally purchases, designs them. And I think one of the things that Mike said that I thought was quite interesting is, you know, the definition of acceptance. If I understood what he was saying correctly, instead of just taking the asset and saying the asset's done, the asset really isn't done until it's enabled. And the enabling piece here is the information systems that go with it, the management, the monitoring systems that go with it. One of the things that the system of systems aspects to me raises is, how do you manage redundancy? How do you manage backup and disaster recovery in where multiple systems are completely interdependent on each other? And I suspect that that has a big impact for those, whether you're the CIO, you're the person that's actually monitoring and managing all the systems, really requires a different way of looking at the world.
Yep. Cora, last minute question to you, and then I'll turn it out to you. You're live.
That's one NFC chip. That's a second NFC chip. Right now, I don't trust the protocol enough to tie it to e-payments, but if I grab my phone from below, it opens my calendar. If I tap it from above, it opens Google Keep. And so the point is I'm adapting, my business process changes. My business process, the process whereby I use technology. The biggest challenge, and I think you've heard it in different ways, is it can inject all the technology standards and discipline that you want, but if people don't change, then you're going to continue to overrun cost and schedule.
Yep. Excellent. So we have time for one question, but again, all of us will be here tonight, so you don't have to worry about us running out of time to join us at the reception later on tonight. But somebody had their hand up, I just saw.
Here.
George? Yeah, sure. You want to get the microphone so we can get it on the recorder over there?
So every now and then I hear that the major part of a construction is after it's delivered. IoT enables monitoring of the building, the environment, and the like after the delivery. Has anybody done a cost model to say investment in IoT and construction projects actually pays off during owner-operator costs?
Yeah, I can address that to a certain degree. When Andrew Wolstenholme took over as the CEO for Crossrail, we had a discussion about the delivery aspects, and he gave me a great analogy that I've never forgotten. He said, I've looked at the cost of this project and other similar projects. Design costs 1, construction costs 10, and those are the areas where everybody fights real hard to get those costs down. The cost of operations and maintenance for the 30 years of that asset will be 100. So at 10 times the factor of design and construction cost, and I'm sure Michael sees the same thing at the MTA. So if you're driving, you go back to the contractual model, Terry, as you talked about, if you're trying to drive down design costs and trying to drive down construction costs and forgetting completely about asset management, operations, and maintenance later on, and not building in those systems in order to do it, you're making a significant bad judgment. So.
But is it a business opportunity for people that are selling IoT to say, I will save you money in operations by investing in that?
The cost model is easy. We've shown very clearly what that cost model is. And that return on investment, you talk to any CEO, you talk to any CFO, as we do, you talk to ministers of infrastructure, as we do, it's a 5-minute discussion when we show what the business model is in terms, what's the return on that investment in a very, very short period of time.
Yeah.
If I might just comment on something that's related but not exactly the same, in the sense that one of our largest clients is a shipping company, one of the largest shipping fleets in the world, and we essentially help them do 2 things. We help them manage and monitor the containers on their ships, which is actually an insurance industry cost mitigation. The other thing that we help them manage is we monitor the fuel usage and the engine performance of the actual ship, which is a fuel savings purpose. We've actually helped this company save millions and tens of millions of dollars in fuel cost because we're actually helping them manage the speed at which they enter and leave port. Some of these ships actually don't even know where they're going when they leave the port that they've just left. They may have 3 different places that they could go, but they literally don't know where they're going. So that's a real ROI-driven example, both on the insurance mitigation side as well as the raw fuel usage that IoT is driving.
Okay. Last comment from Michael.
Yeah, I want to leave this kind of the ROI question to recognize this one thing that Cora was emphasizing, that the ROI really depends less on the technology and more on the change of the business model. So as a provider of the technology, if the institution is unprepared to change the way it does business, it's not going to realize anything value from that technology. And the second thing, guess this was, is that this is really an ecosystem. So if one of us changes and the rest of us doesn't, we all, we're not going to realize the value. So we all have to change together. And that's one of the reasons why, I guess, Norm's concept of putting out a kind of a real vision for infrastructure in the United States and start changing the rules by which we behave for the purposes of not of finance and not of contracts, but for cultural and social outcomes is really going to be necessary to get us all to change our behaviors in a fashion that's coordinated. And right now, our diverse interests, our silos really are going to prevent us from coordinating in that fashion because we're not looking for win-win opportunities. We're looking for what's in it for me by myself in my interests. So until you get out of that mindset, we're not going to realize the value from an open technology model.
So I'm going to close this down with one last quote to Michael's point about change. Andy Grove from Intel said this a decade ago: if the rate of change outside your organization is faster than inside, the end is near for you. So, hand for our panel, and thank you very much.